everyone. Thanks for taking a look at my channel and welcome. So, in my channel, I talk about some of the tech stuff, usually with big data pipelines, data-intensive applications, and writing better Python code, and giving some tips and tricks to um, make you more of a complete programmer, maybe from beginner to intermediate or advanced, and know those tricks to write more elegant code. And one part, maybe, I think I've never talked about designing data applications or probably designing data pipelines. So I thought I can address that here and taking some scenario and try to give some insights, because most of the data pipelines that are written today using cloud tech and open source or whatever it is, managed or unmanaged, it follows a common pattern as we see here. And I have seen this pattern to be really successful in most of the cases in different domains, maybe yeah, e-commerce domain, or maybe meta search engine domain, or whichever it is. I think you would really see this kind of pattern uh, throughout. And we can expand on this pattern, but then basically I just wanted to show you that's what's the skeleton of a system design, designing what is that you think about when you think of writing system design for a big data application, um, especially batch analytical application. So uh, firstly, every batch application, most of the cases would get source from an upstream. It would have an upstream source where it would rely on some data to be imported. So it can be either other databases, it can be either other cloud providers, or maybe even other third-party APIs through which you want to import some data, and maybe there's an ask to give some insights for maybe number of users. Let's say in this case, number of users visiting a particular website. Um, maybe their user ID, maybe their how do you segregate them? What is the number of users and unique users maybe, or the actions they perform, logout, search, and things like that. So uh, if there's a requirement, let's say I want to find for my particular website, I want to see the number of users, the actions that they take, login, logout, or search, whatever action it is. Depending on that, I might take a decision. So uh, if we consider that as a use case, mostly we would want to receive that data from another application. Mostly it would be an third-party API application. Let's say if I can find the right um, if I can find the uh, right icon for it. So maybe through an API gateway, and yeah, so this would typically be it. You are accessing that through some kind of Kinesis stream or any other, even if it's just a Python third-party Python application, you can just write your application on your own, and you try to ingest that particular data and try to put it into the loading stage. So that's the first stage. Loading stage, or the staging, is a place where you typically want to have your data, so that you can start your insights from. So that's how that's the initial stage. There is some data lying somewhere, maybe web logs from a third-party web application, that you go through an API gateway and try to fetch that data, or maybe it's available through some REST endpoints, and you want to fetch that application every now and then and put it into Kinesis. So that's going to be another component here in between. Yeah, that would be a stream. So that stream would get that data from different application. Maybe it runs every minute or so and put it into Kinesis topics, or maybe it directly lands the data to S3, or maybe you have a Python application or any other application that just hits the REST point, API REST point, and you get a JSON response, maybe about the server logs and things as such. Then you put it into the loading stage, the staging environment, from which you would actually carry your that's the initial part of the data ingestion process. So when designing data applications, you probably want to think of few things initially, uh, before anything else. The first thing would be the idempotency, because data pipelines break and the upstream sources break, issues would arise most. It's really common for data, any or data not only for data, for any other application to have issues. So there's going to be partition and things as such. You have to handle that. So that's inevitable. And we have to think of writing an application item in an idempotent way. So meaning that you rerun the application and you get the same results. Any number of times you rerun the application, it's going to produce the right results. And the next thing would be the data quality checks, minimal data quality checks. Uh, that you would need, so that you can avoid the headaches later in time. And then probably schema evolution. So I wrote the list here. So schema evolution, or how the product is going to evolve, you have to think about it at least before actually thinking of writing the pipeline. And finally the scale, is it going to scale? And um, you don't want to design the state of the art system initially, even at the start, but then it's good to think about scaling, because data pipelines evolve and you get huge loads of data than you expect, and you want to address that. So there's going to be a transformation phase, uh, and then finally there's going to be querying stage. And yeah, it's as simple as that. So I'm not kidding, but then there are more things under the hood. So for example, how would you actually load the particular data from a third party application to an S3 bucket? Or maybe let's say you are an AWS shop and you want to store that location on a data lake. How would you do that? So the first thing is to have an application and fetch the data for a particular day, and write that data to a bucket, which is in that bucket you should have a directory. Let's say for this particular date, for example August 5th. So you would have this data for um, that date, and you have that run for that date. So you have the data for that particular date. It's just that exclusively for that date's run. It doesn't have any data for the other dates. So that's crucial here. And the next thing is to have a transformation job. Like this is typically in a big data environment, it's going to be a Spark job, or maybe Pandas, or any other job if it is not so much data. So it's going to have uh, it's going to have Spark job, mostly PySpark, and that's running on top of any managed service like Databricks or EMR, or maybe Dataproc if you are using Google Cloud. So you would typically write a transformation application that's kind of like a silver layer if you think of medallion architecture. So I can talk about that maybe later sometime, but this is a really simple use case. So you're going to have that application that's going to enrich the data that you want. Maybe you want to fetch data from different sources, like let's say you have a database, uh, and you want to actually enrich data from there, and you want to join that data so that you can bring some insights over to the application. So the thing is that the main idea here is to remove the duplicates, pre-process the data and store it into a format, let's say in Parquet. That can be, let's say if I can find a template for Parquet. No, I guess. So Parquet is a format that's really good for the analytical use case. So you store the application, store the intermediate results in Parquet, that's in date partition, so that it can be queried faster, because Parquet has other benefits. It's a basically an analytical storage. So it's storage designed for analytical purpose. So yeah, so that's really good. And you want to partition the data sets in dates. So for example, if you want to, the reason for partitioning it in date is actually to have the idempotency in mind. And also most of the reports would be run on a daily basis, and we have to find insights for each date. So if you are in Parquet format and partitioned on date, so you can easily fetch just the data for that particular date that you want, and you can to your computation. And finally, you're going to write the table in, again, maybe in a store like Hive or any other store that is partitioned on date. This is again crucial, because so you don't want to create new set of data, new versions of data. Let's say if you are trying to uh, rerun the job, if there's a failure in between and you want to rerun the job, or maybe the computation is there's an error in the computation, there's a data quality error, so you are trying to eradicate that error. You have to push that fix in, and then finally you just have to rerun the pipeline. So you want to delete all the old data and rerun the pipeline, and uh, the pipeline has to take care of that automatically. Either you have to do it by yourself or make use of Hive. Let's say as an example, you have an unmanaged Hive table that you write the data on top of that. So it doesn't make sense, and you kind of like repair the table after you write the data set. So in that way, this case is handled, and this would be an aggregated data set. It's like, for example, if someone fetches one particular row from this data set, it's going to be an aggregation. Let's say for a particular day, for a particular user, you have multiple user IDs. So it's if you want faster results, you can partition on user ID as well. So for a particular day, if particular user has performed so and so operations, and these are total number of operations and things as such, and on aggregated scale. So if you could expose that, that would be great. That would be the final piece of the puzzle. Let's say you can use technologies like Hive, and you can use technologies like delta tables. Delta tables are really good because there's this growing trend of delta lake and lakehouse architecture that's really helpful to use, really expandable and self-managed, takes away a lot of headaches that used to be there in the Hadoop age. And all this can be orchestrated through Airflow. Airflow is the industry standard now, I guess. There are other tools, by the way, but uh, Airflow has been used most intensively, most extensively by many large corporations. So you schedule a job, this job runs every day, so you get the report in, so that can be consumed by maybe traditional BI tools or visualization tools. Let's say Redshift. Yeah, so let's say it is going to be consumed by business. So this is how it's going to look like. So this is the main idea of the data set, and this is called the this is kind of like uh, it's actually related to the medallion architecture. Um, but medallion architecture is a bit more to this than just these three blocks. Uh, but but this is going into that approach, and there's something called a silver layer, and the final exposed table is called a gold layer. So you can use Redshift and other technologies here to expose that table. And the silver layer would be a table as well, but that's for the internal computation, or can be used by other systems if it is exposed. And the reason why it is silver table is because it doesn't have the aggregation. And also there can be two things that you can think of at this point. One is the final table can have a wide table. uh, Final table can be a white table, or the final table can be a table with just facts and dimensional modeling, and maybe in a dimensional model way, maybe it can be a star schema based. So you kind of join with different data sets, and you aggregate things, and you aggregate things and you give the results. Or maybe it can be a white table, as I mentioned. You have all the dimensions and facts within the table, so that you just pick one row and you are done with the computation. Sorry, not the computation, but the results that you want. So yeah, so this is the basis of any data application, batch-based data application nowadays, modern batch-based applications. But there are some workarounds, though. There are some other approaches which are coming into picture nowadays. But uh, but but at this moment, it's not as common as this pattern. So I think if you go anywhere in any organization, if there's a batch application and that's running in the cloud, I think you would see these three diagrams, staging. And there's a middle layer and there's a final layer. So yeah, this is just to make sense of that, to just give an overview, just to give an idea to you about this. So I hope this video has helped you. um, and yeah, this is the start of your data journey maybe. So I think it gave an overall idea of what are the technologies, and um, what's the approach that you take, and what are the things that you think of while writing the application. And definitely SLA is one of them. I think I didn't mention it here. So yeah, so that's about it, I guess. So yeah, thanks for tuning in, thanks for watching the video. I hope this has helped you. Until the next video, bye.